Okay, so this video is going to be on probability. The first thing we're looking at, rule number one, is the addition. That is for or. If we're doing the probability of this or this occurring. Now, there's two ways that we can write it out. That is using just the word or using the union symbol. Okay, which is kind of looks just like a U. The addition rule, the or, comes in two parts. There's two different formulas that we have for it. One is for disjoint events and one is for non-disjoint events. And we'll get into that in just a second. It says if two events E and F are disjoint, the probability of E or F is, that is the probability of E or F occurring is equal to the probability of E plus the probability of F. And so that's why we say this is for addition. So if we have an or, you're just adding the two separate probabilities together. Okay, and that is if they are disjoint. Now, as far as disjoint, what that means is the two things are not related to each other at all. They have nothing in common. So if we looked at a Venn diagram of that situation, E would be contained over here, and F would be contained over here. And you'll notice they don't share any parts in common. Okay. Now, if the two events E and F are not disjoint, that is, they share something in common. So you might see this as a Venn diagram like this, where you have E and F, and then you have this one part in the middle. These are the things that they share in common. So if they share something in common, if they have a part that overlaps, then they are not disjoint. So if two events E and F are not disjoint, the probability of E or F, and again we can write it or we can write the union symbol, is equal to, so the probability of E or F is the probability of E plus the probability of F, which you'll notice is the same from above. However, because they have that part in common, we have to subtract off the part that they have in common. The problem that's going on here, the reason we have to do that, is because if I add in the probability of E, I'm adding in this part right here also. So if I add in the probability of E, that's all of this information here. Then if I go back and add the probability of F, like I am in that second part, then I'm adding all of this section here. So not only have I added this middle part once, but I've added it now twice into that probability. So what they're saying here is, that's fine, you've added it in twice, just subtract it off once. So that way it's only put in once overall. So number one is the probability of red or green a disjoint event. So here we're trying to figure out is for disjoint, the reason I need to know that if it's disjoint or not is that I need to know which one of these formulas up here to use. If they are disjoint, then I can use this top formula, but if they are not disjoint, then I've got to use this bottom formula. So what they mean here, this is a good example of this, is for disjoint, that means they're all solid colors. They don't share any colors. Okay, or at least as far as red and green, there are no red, like half red, half green marbles in a set. So if I look here, this is solid red, solid red, solid red, red. This is solid green, green, and green. There's no half red, half green marbles. So since they don't share a marble, they are in fact a disjoint event. There is no red and green marbles. What formula can you use to calculate the probability? All right, since it's disjoint, again, we'd be using that one formula up there. And so the formula that we can use is the probability of red or green. And again, you can use or you can use that union symbol. Okay, is just simply the probability of red plus the probability of green. Okay, and next, we want to find the probability of red or green. So all I've got to do is find the probability of red, find the probability of green, and then add those two probabilities together. So if I look at here, the probability of red, that is, there are 4 of them out of a total of 12 marbles. Okay, so 4 out of 12 of them are red. 3 of them out of the 12 are green, and I just add those two probabilities together. Right? 4 twelfths plus 3 twelfths would give us 7 twelfths. And there is the probability of red or green, given that they are disjoint events. Number 2, what if the purple is, the probability of purple is equal to 0.14, the probability of blue is 0.26, If there are only purple, blue, and orange marbles, what is then the probability of orange? So there's a couple things going on here. They're telling us all of the colors. In fact, there are only those colors. The sum of all the probabilities for the sample space, for all the different types, if you added up all the probabilities for all the different types, it should always equal to 1. So if I know the probability of these two right here, I should be able to figure out this one because I know all three have to add up to be 1. Right? The sum of the probabilities of purple, blue, and orange must be 1 since that's all there is. So then, the probability of orange should be equal to 1 minus the probability of purple plus the probability of blue. So if I add the purple and the blue together, right, and then subtract them from 1, I should be able to get the probability of orange. So here I can look at that. The probability of purple was the 0.14, probability of blue was 0.26. If I add those two together, I get 0.40. So 1 minus 0.40 would be 0.60. So the probability of orange should be 0.60. The second part of this problem is, well, now that we know what orange is, what is the probability of drawing a purple or an orange, say, marble? Okay, so again, since it doesn't say anything about them being disjoint or non-disjoint, we're assuming that there are only purple marbles, there are only blue marbles, there are only orange marbles. There's no half and half or anything like that. So we're looking at the purple or orange, so I should be able to just add their two probabilities together. Right, so the probability of purple was 0.14, the probability of orange, which we just calculated, was 0.60. Add those two together and we get 0.74. So the probability of purple or orange is 0.74. So again, whenever we're looking at an OR situation, we're just adding the probabilities together. And that's for disjoint. If they are non-disjoint, you still add, but then you just have to subtract off that part that they have in common. Okay, so now if you'll notice here, our marbles have different parts to them. They're kind of mixed up a little bit. Okay, so now we're going to look through here, and we're going to find the probability of orange. Well, the problem here is that one is solid orange, but this one also has orange in it, so it's counted also. This one has orange in it, so it's counted also. So in fact, there are 1, 2, 3, 4, 5 marbles in here that have orange in them. So there are 5 out of 12 marbles that have orange. So the probability of orange would be 5 out of 12. All right, and the next one for red, the probability of red is there are 1, 2, 3, 4, 5, 6, 7, and 8 marbles that have red in them. So the probability of red would be 8 out of 12. If I look at the probability of green, right, there are 1, 2, 3, 4, 5, and 6 marbles out of a total of 12 that have green. Now, if you type some of this into the calculator, obviously it'll reduce those fractions for you. All right, so for example, an easy one would be 6/12 would just be 1/2. Okay. Now I'm looking for the probability of red and green. When I say red and green, those are the only ones that contain both of those colors. An and means they have to meet both of those criteria in this case. Okay. So I'm only looking for the ones that have both red and green. So there's one there. There's one there. This one has red and green. It also has orange, but that's okay. It has red and green. All right, same thing down here. This one has red and it has green. Okay, so there are 1, 2, 3 marbles out of 12 that have red and green. Okay. Is the probability of drawing a red or green disjoint? Okay, remember, for it to be disjoint, they cannot have any that have the same colors in common. If I look here, this one right here has both red and green, which means they cannot be disjoint. They have to be non-disjoint. That is, you have some that have the same colors. These are non-disjoint because there is a marble, at least one marble, that has both red and green on it. In fact, there are multiple marbles that have both red and green on it. But as long as there's at least one, they are not disjoint. So in this case, what is the probability now to draw a red or a green? Right? So now, since they are non-disjoint, yes, we still add their probabilities together. However, we have to subtract off the part where they coexist, the part that they have in common. Okay? A Okay, and so now we're going to be finding the probability of red or green. Now, according to the formula here, I'm going to find the probability of red. I'm going to add in the probability of green, and then I'm supposed to subtract off the probability of red and green. Now, this is kind of why I have to subtract that off. Well, if I'm doing the probability of red, the probability of red up here is 8 out of 12 because there are 8 of these that have red in them. There's this one here, there's this one here, there's this one, here, 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 and here. So when I do that probability of red, I'm kind of throwing in all of those there. Well, if I do the probability of green, now that means I'm throwing in this one, I'm throwing in this one, I'm throwing in this one, this one, this one, and this one. Well, kind of the problem is when I add those up, I've now added in these 3 twice. So what that subtraction is, that subtraction of probability of red and green is, what it's telling you to do is just, okay, that's fine, you've added them in twice, just go back and subtract them off one time. And so now, you've only counted each one of those marbles only one time. Okay, and so that's why down here, we see the probability of red is 8 out of 12, plus the probability of 6 is 6 out of 12. But again, some of these marbles are the same marbles in here. And so that's why we're subtracting off that 3 out of 12. 8 out of 12 plus 6 out of 12 minus 3 out of 12 will leave us 11 out of 12. So in fact, what this is telling me is there are 11 out of the 12 marbles up here that either have red or green on them. And in fact, if you notice kind of my lines up here, the only marble that did not get marked is this marble right here. It's the only marble out of the entire bunch that doesn't have red or green on it. So there are 11 marbles up here that have red or green on them. Okay. Number 4, find the following probabilities based off of the Venn diagram. So if I look at the probability of Coke, okay, this should be a review of another video you've done. If I look at the probability of Coke, just Coke is all of this information here. All right, this is all of Coke. So if I want to find the probability of that, I'm going to have to add those 2 numbers together. Not only that, but since I'm doing probability, I've got to add all of the numbers in here to get a total. If I add up the 21, 48, 56, 11, 3, and 9, I believe I get a total of 148. Right? And so if I add up the probability for Coke, that'll be 21 plus 48 over the total of 148. Add the 21 and 48, and we get a total of 69 out of 148. So the probability of Coke, there are 69 people that like Coke out of a total of 148 people, maybe. Okay. For Dr. Pepper, again, Dr. Pepper is all of this information in here. Some of these people, yes, like Coke. Some of these people, yes, like Pepsi. But it's okay. All it's saying is Dr. Pepper, so that's everybody in that circle. So we're going to be adding up 48, 56, and 11, and then dividing it by the total of 148 to get the probability. And so that gives us a probability of 115 over 148. For Pepsi, again, we're looking at all of this circle here. So that's 11 and 3. 11 plus 3 over 148 will give us the 14 over 148. And finally, the probability of other. The other are the people that don't like Coke, Dr. Pepper, or Pepsi, so that's the people on the outside. And there are a total of 9 over 148. So there's a probability for each one of those little sections. Now let's go back and look at what happens if we have an and or an or. If I look at an and, I'm looking for the probability of Coke and Dr. Pepper. Now in this case, we're not talking about 2 separate events. It's just we're looking for something that meets both of these criteria at the same time. We're looking for the people that like Coke and like Dr. Pepper at the same time. The only people that like Coke and Dr. Pepper at the same time are these 48 people. So my probability would be 48 out of the total of 148. Dr. Pepper and Pepsi. Dr. Pepper and Pepsi. The only people that like Dr. Pepper and Pepsi are those 11 right there. So my probability would be 11 out of 148. For Coke and Pepsi, I'm looking at Coke is way over here. Pepsi is way over here. Those 2 circles do not overlap at all. So there are no people in there that like both Coke and Pepsi. So its probability would be 0 people out of 148, or a probability of just 0. Okay, and so now I'm looking at the probability of Coke or Dr. Pepper. And again, this is where we're going to start adding, right? For or, you add the probabilities together. So if I'm looking at Coke or Dr. Pepper, Coke is all of this information here. Dr. Pepper is all of this information here. So I'm going to be adding all of these values here. So I got 21 plus 48 plus 56 plus 11. Now, if I add 21, 48, 56, and 11, I get a total of 136. So that's the total number of people that either like Coke or they like Dr. Pepper. Some people do like both, and that's okay. Or is very unrestricted. It's like as long as they like one of them, they're good to go. Yes, these people over here like Pepsi, but it's okay. They like Dr. Pepper also, so they're part of that. So again, my total is 136, and again, we're doing a probability, so this is out of the total of 148 people. So the probability is 136 over 148, which, yes, if you use your calculator, could be reduced. We're looking at Pepsi or Dr. Pepper. All right, Pepsi is all of these people over here. Dr. Pepper is all of these people over here. And so I'll be adding up all of these values over here. And it's okay that some of them overlap. Yes, these people like Coke, but again, it's okay. They like Dr. Pepper. These people right here like Dr. Pepper and Pepsi, but it's okay. As long as they're a part of one of them, they're a part of their union. Okay? So again, we're going to be adding these together. All right, so I'm doing 48, 56, 11, and 3. 48, 56, 11, and 3. Give me a total of 118. So again, that'll be out of the total. So I have 118 out of 148. Dr. Pepper or other. If I look at Dr. Pepper or other, that's all of these people here. Those are all the Dr. Peppers or the others. So I'm going to be adding up all these and the 9. So 48, 56, 11, and 9 give us a total of 124. So again, that's out of the total of 148 people. And last but not least, I have Coke or Pepsi. I have all my Cokes and all my Pepsis. I have 21, 48, and 11, and 3. If I add those up, 21, 48, 11, and 3 gives me a total of 83. And again, that's out of the total of 148 people. And so there we go. There's or and using the Venn diagram. Okay, so now we're going to look at another problem. Number 5 says a large auto center sells cars made by many different manufacturers. Three of these are Honda, Nissan, and Toyota. Suppose that the probability someone buys a Honda, Nissan, or Toyota is as follows. The probability of a Honda is 0.25, the probability of a Nissan is 0.18, and the probability of a Toyota is 0.14. First are these disjoint events. So if we think about this, should these be disjoint events? Yes, since in general, when you go into a car dealership, since you cannot buy a car that is both a Nissan and a Honda, for example, these should be disjoint events, right? They don't share anything in common. You don't buy a Toyota that is half Toyota and half Nissan, or a Honda Nissan that it's half Honda, half Nissan. So they are disjoint events. Okay. The next part, what is the formula you're going to use to find the following? Okay, so I'm looking for the probability of a Honda union, that is or, a Nissan, or a Toyota. Okay, since these are disjoint events, all I have to do is add the probabilities together. So that's the probability of a Honda plus the probability of a Nissan plus the probability of a Toyota. So what if I want to find that, what is the actual probability? Well, since all I have to do is add them together, the probability of a Honda, which is 0.25, plus the probability of a Nissan, which is 0.18, plus the probability of a Toyota, which is 0.14. That gives me 0.57. Okay, so the probability of a Honda or a Nissan or a Toyota is 0.57. So in this case, there are apparently also other vehicles there, because they don't add up to be one. So that is not the entire sample space. Right? So there are maybe some Dodges or Chryslers or something else there. Let's see, number 6. Musical styles other than rock and pop are becoming more popular. A survey of college students finds that the probability they like country music is 0.40. The probability they like jazz is 0.30. And that they like both is 0.10. What is the probability they like country or jazz? So first off, are these disjoint events? So if I'm going to look for the probability of country or jazz, that's again that first thing I have to decide to make sure that I'm using the appropriate formula. Now in this case, no, these are non-disjoint. They are not disjoint. They have something in common, in other words. Because up here it says that since some people like both, some people are in both groups, that is, right? We see that the 0.10 up here, those are the people that like both country and jazz. So they share something in common, so that's why they're non-disjoint. Okay. Write the formula you're going to use and then solve it. So if these are non-disjoint, then yes, I'm still adding them together, but again, we got to subtract off that part that they have in common. So I'm looking for the probability of country plus the probability of jazz, minus that part that they have in common, the probability of country and jazz. So bringing those in, country is 0.40, jazz is 0.30, and the probability of country and jazz, the part that they have in common, is 0.10. So 0.40 plus 0.30 minus 0.10 gives us 0.6. So the probability of country or jazz in this case would be 6.6 or 60%.